Hello, Sevens. Welcome back. So I just wanted to give directions to the people coming back in the afternoon on Thursday, the 30th of April, because some people join at different times. It'll speed things up when you guys join. So this morning you guys were catching up and there's directions in there. This afternoon, I want you guys designing a sports bag. This will be our last geometry assignment of the year, I think. I guess I'd have to double check the standards, but I'm pretty sure this is our last geometry assignment of the year. So when I open this, I hope, by the way, that this is an interesting application of some of the geometry we've done. Like, I think it is. I hope you agree. So I say, part of this assignment is obligatory, and the other part is optional for extra credit. That's important for you to know, and you'll see them. The obligatory assignment is outlined here. I give you a hint for doing it, and then there's the optional assignment for extra credit. So, setup. After university, you decided to open a graphic design business, which is awesome. Like maybe you just really like drawing logos or creating things that help people optimize their businesses, whatever, but you open a graphic design business. You put out a couple textiles. Textiles are things like shirts and clothing and blankets. So you put out some of those things and found some success. So you put out your designs, people are buying, it's great. As a result, Nike has asked you guys to design a sports bag. So this is up to you to design a sports bag that Nike is going to sell with their emblem on it. They've sent you some information. The information is attached. It's inside this attached PDF. Mathematicians call information like this constraints. So I will use that word as I go to it. Constraints are helpful as they make the solution set smaller. If there are no constraints, the solution set is huge. But if you constrain it, now you have a small solution set so that you can apply your creativity to the problem under the set of solutions that is left after the constraint. So basically the constraint makes the solution set smaller, so there's a smaller amount of things for you to apply your creativity to and come up with a quality product. It usually makes things easier, which is why mathematicians like constraints. So the obligatory assignment, this is the piece everyone must do. According to the video and the attached document, this video that I'm making right now, and the attached document right here, you must give a technical drawing of the pieces you'll use to assemble the bag. If you read problem 1, it's literally what it asks for. Just make sure that you give actually a technical drawing of the pieces you will use. You must also diagram those pieces placed on a 1-yard fabric. 1 yard is 36 inches wide. And this is because Nike is an American company, so they've asked you to do these things under American measurements. So I want you to also diagram them on a piece of 1-yard fabric. I'll show you what I mean, and give the shortest amount of fabric you'll need in order to make one bag. And this is what problem 2 asks you for. So it's also on the attached. The hint I'll give you is that you will need to understand the surface area of a cylinder in order to complete this task. If you don't know that, you might want to watch the video in that section on LMS. So go back there, watch that video, understand how the surface area of the cylinder is put together, and then I bet you'll be able to do this. The optional piece for extra credit is that after you've come up with those diagrams, now you have diagrams of what these things look like, go ahead and design the whole bag. Like feel free to draw on paper using diagrams like those you used for the assignment above. Or you can do 3D drawings of the bag like at the top of the attached, and I'll show you when I open it. Or you can use any digital methods you know to create the design as well. So if I open this, when you design the bag for the optional assignment for extra credit, you could draw it like this. You could draw it like what you'll have at the end of this, I'll show you, or you could use anything digital. However you want to show what your bag will look like, it'll be fun to see your guys' creativity. So you're designing a sports bag. You've been asked to do it. Here are the constraints of the problem. One is that the length of the bag will be 20 inches, and I forgot to take out my drawing tools, sorry. The length of the bag is 20 inches, so what I mean there is that this dimension is 20 inches. The bag will have circular ends of diameter 11 inches, so circular ends of diameter 11 inches. I'm talking about these circles on the end have a diameter of 11 inches. So those are constraints. They take the solution set of all the possible cylinder bags that you could create, and they make it a small solution set. And that's great because you can apply your creativity to it. The main body of the bag will be made from 3 pieces of fabric. So I'll say those 3 pieces of fabric are a piece for the curved body, which is like this piece going around there. And the two circular end pieces. That's like this circle on the end and this circle on the end here. So you basically like this piece is like a long piece. It's that lateral surface of the rectangle or the cylinder. And then we have the two bases, which makes sense. There's three pieces. When cutting out the pieces for the bag, each piece will need an extra ½ inch. I'll show you what that means. Like you're gonna sketch these things. Oh, and I should show you two, this is gonna become another messy rainbow. Fabric, 1 yard wide. What that means is when you buy fabric, and I don't know if you've worked ever before with fabric and sewing and things, you buy fabric and it's like you get a certain width. In the United States, it's almost always 36 inches wide. But you can buy whatever length you want. So this dimension, you get to choose based on how much you're making. We signify that by saying this thing is like broken like that. Just saying like it can go on forever. So then we diagram the things. So like the two circles on the end are obviously circles. You'll have those pieces. You'll also have the other piece. I'm going to leave that as a question mark. I want you to diagram it and draw it on these things. And on top of it, here's what I'm saying here. The seam allowance is important if you've ever worked with these things. We need an extra ½ inch seam allowance, which means if you actually want the circular end to be this big, then when your circular end is that big, to make a seam allowance, you need to go ½ inch bigger everywhere around. And the reason is because if you picture this piece of fabric on the end, like it actually has to fold in here at the end, and the purple piece, this piece has to also like fold in the other direction on the end, and that way you can sew them together so there's extra fabric inside. That's what this is. Every piece you draw has to be an extra ½ inch bigger on every side. So good. First, I want you to make a sketch of the pieces you'll need. That's already described, and yeah. And then you needed to make a sketch on the 36 inch fabric or on the 1 yard wide fabric. And then what is the shortest length of fabric? When you put all the pieces here, what's that shortest length here? Like where does that end? Because that would be like money savings, you know? The less fabric we use, the more bags we can use from smaller fabric. I feel like I'm probably talking too much and you understand this. So make sure you answer these two questions and do what they ask for the obligatory assignment. And then for the optional assignment, you can go on and actually design, like what does the design look like? Feel free to submit that however you'd like. I gave 3 options there. That's all I got. Best of luck, Sevens. Have a great day. Bye-bye.